We're going to go over how to use the load span table to figure out the spacing that we can have on our truss system for a poured concrete floor on a second level of a commercial building. And so here are our design constraints. We have a span of 10 feet and we have an applied load of 200 pounds per square foot. This number can be found in the code books depending on the use of the facility and the area and size of the space. So the first thing we'll want to look at, let's go ahead and I'll zoom in here on our diagram so you can see what I'm talking about. What we have here is a second level of a commercial building. We have a poured concrete floor that's going to go in the building, and we're saying that between these trusses, this span is 10 feet in our design. And so it's going to tell us, the table's going to tell us how thick do we want this concrete to be, and how thick or what gauge of metal this metal webbing should be underneath the concrete that's supporting it. All right, and so if I look up here at our table, we'll explain this really quickly. Here we have the slab depth, or how thick the slab is. We'll talk about the unshored clear span in a minute. I'll come back to that. And here we have our clear span in the number of feet. And so we're trying to design the most efficient use of materials. And so in our case, we have a 10-foot span. And so I will find the 10-foot right here. And we have a design load of 200 pounds per square foot. And so I'll come down until I find a number that is less than 200 pounds per square foot. Excuse me, I said that incorrectly. We need to find a number that will support more than 200 pounds per square foot, but we want to do it as efficient as possible. And so in this case, 198 is not enough support, and so we have to go to the next number, which is 245. And so if we want to have a span of 10 feet with 200 pounds per square foot of applied force, we would have to use this table right here to figure out the concrete that we need to use. And so it's telling us that our slab depth for that span is 4.5 inches. And so that's right here. And so I'll write down here where I have slab depth, I will type in or write in 4.5 inches. And then we can come over here and we can look at the deck type that it recommends. And so if I go across with my table, the deck type is right here. It's recommending that we use 16 gauge steel for our deck type right here. So I'll write that 16 gauge. And I'm going to go ahead and on our diagram down here, I'm going to annotate that. And so this is going to be 4.5 inch. And our deck type is going to be 16 gauge. All right, the last thing that we need to look at is the allowable unshored clear span. And so that's this column right here. If we look at this chart, this column, we can see that we have three numbers here. A number for one span, a number for two spans, and a number for three spans. And so if I come down here, we'll make another little sketch. This is an example of one span. Two spans would be like this. So we're spanning two spaces. So this again is our concrete decking and floor, and here are the number of spans we're making. And the last one, this would be a three span. So if we come back up here and look at our chart, it says allowable unshored clear span. And so what that means is that if we shore up something, we are going to put extra support between them. And so if I wanted to shore this span up, I would put something else right here to help hold it up while the concrete cured or dried. And so it's telling us here that on our chart that if we have one span, we can only span 8 feet 8 inches, which is less than our 10-foot required. And so if we're spanning just one 10-foot gap, we have to have some type of support underneath that to hold that concrete and the decking material up until it is completely cured. And so in this case, if we had one span, we would need it. If we had two spans, that's greater than our 10 feet, and so we don't need it. Obviously, if we have three spans, we still don't need it. And so if we were just having a building that was 10 feet and we only spanned that 10 feet, we would need to shore the middle of that span up with some other temporary support until the concrete cured.